Hi everyone, welcome to Fabric Espresso series about data engineering and data science. My name is Estera, and today Eren is joining me to discuss model scoring with a predict function. Eren, thank you for being here.
Yeah, thank you so much for having me, Estera. So I'm excited to show off some of the capabilities we have for getting started with predictions in Fabric.
Super. So just quickly jumping to the topic, because I believe that as a data engineer and a data scientist, predict is something that we think that we have a data and let's imagine we have a table and we have a column and we want to predict the value of the column. For example, we want to predict what will be the stock price within a week, within a month. And the gap, how to predict, meaning that I have a table, how to run a predict method on that table is something what we will discuss today, right?
Absolutely. So I can take you right into the experience and get started.
Super, but maybe for new folks who are just starting with exploration of this topic and who are hearing for the very first start the concept of model training and also model inference and model scoring, can you explain those terms?
Absolutely. So a prediction with a model refers to the application of that model to data that it hasn't seen before to do its job, which is to predict, to tell you what it expects the value to be based on those inputs that you're feeding it. So when we're talking about model prediction, model deployment, we're referring to a stage in the machine learning lifecycle where you've already done a lot of the hard work. You've taken your training data, you've cleaned the training data, you've trained a model on it, you've gone through a bunch of iterations, maybe you've done some hyperparameter tuning. Now you've gotten to a point where you have a model, it's registered for use, and you want to show that model data that it hasn't seen before and see how it's going to do. Is it going to predict sort of the values that you expect? So in a scoring scenario, that's kind of what we're referring to, seeing how well it would do. And then ultimately in production scenarios, you're relying on that model to feed you predictions based on the work you've done training it.
So the next step, what is a predict function?
So I'm going to take you into a Fabric workspace to show off the predict function. Now, predict is a scalable function that we have offered. You should also check out the SynapseML library, which is a bunch more exciting operations and sort of features for code-first machine learning. But we're going to limit today's session mostly to just talking about predict and how you can use it to get batch inferences. So these are predictions done on usually larger sets of data. They're asynchronous. We're going to load the model into a notebook, feed it data that kind of conforms to its expected inputs, and then get those predictions, take a look at them, maybe write them back to the lakehouse and do all sorts of stuff from there, whether you're dashboarding, sharing that data with others, and so forth. So if you're in a Fabric workspace, you might be familiar with the two data science dedicated artifacts that we have, the machine learning model and the machine learning experiment. Models are registered from runs in those experiments. And so I'm going to start from this assumption that you've already trained a model, you have it in your workspace. Maybe, as is often the case, one of your teammates has trained the model. So you weren't even the one doing that work. You now just want to take advantage of the work that your teammate has done and collaborate to actually apply this model to some new data. If you have a registered model in Fabric and you have input data that the model is going to expect, you can get started with predict. So I'm actually going to click into this churn model artifact here in a Fabric workspace. And here we can take a look at some of the properties of that model. We see on the left that the different versions of it have been logged. We can take a look at some of the metadata associated with those versions, whether that's the name, the time it was created, the experiment that corresponds to it, and we can even look at metrics that might have been logged alongside those model versions. So what I want to pay attention to here, though, is this input schema. So we see here that for this churn problem, the model expects a certain amount of information in a specified format in order to be able to give you the predictions that you want. So here we have a credit score, age, tenure. We see that these are numeric values. In this case, they all seem to be numeric values, but there might be categorical values. And then there's an output schema too, which here is a tensor, and it's going to contain those prediction values that we want for this churn problem. So what we can do from here is go to this apply this version button if this is indeed the model that we want to apply, and we have two options. I'm going to show you both, but let's just start with this copy code to apply. So if you don't know how to invoke the predict function, you can actually go ahead and take a look at this template here that has preview code snippets that's going to show you everything you need to work on a prediction problem, basically. So you have a line to specify a file path, a table path in this case from the lakehouse perhaps, for the input data. That's the data you're feeding to the model. You have an instantiation for this ML flow transformer, which is going to handle these predictions. So you need to give it information like which model you're using, which version. In this case, it's the churn model version 6. That's pre-populated. And then some information about the input columns that it's expecting in order to be able to provide the predictions. And then the prediction really just comes down to the simple model.transform line, which is going to be put into a data frame, a Spark data frame, and then we could write that back to a table. So the idea of this experience here is that if you don't want to go and look at the documentation, you can kind of just copy it to the clipboard and go and get started in a notebook. Now, I already have a notebook, so why don't I navigate over there once I've shown you this model artifact as we've just done to see how you can get started with batch predictions. So as I've mentioned, Microsoft Fabric allows users to get started with batch predictions using this function called predict. You can generate batch predictions here directly from a notebook, and there's also a code generator experience from the UI that I can circle back to after on that model artifact page. So what we're going to do to start is just take care of some of our import statements. So I'm going to run this cell, make sure we have ML flow and Synapse ML in there.
If I may to jump here, you mentioned ML flow is there. A lot of our customers are asking if we support ML flow. Can you comment on that?
Absolutely, yeah. So we are integrated with MLflow. MLflow is an open source platform for tracking the machine learning life cycle. There are a lot of features we could get into. Probably that would require a separate espresso session and a whole new cup of coffee, but we're built on top of MLflow. So you have experiments as the kind of logical containers for work a data scientist is doing to train a model. That experiment in a training situation is going to contain different runs, training runs that corresponds to an execution of training code for a model. And then based on how those runs go, you can register model versions from them. And that's how we get to that model artifact that I just showed. So we integrate with MLflow in that way. And that's the kind of paradigm that users coming to Fabric can expect. And then any model that has been registered in the MLflow format is a Fabric artifact, first class, that you can use to generate predictions, as I'm going to show you. So once we take care of some of those imports, the first thing that I'm going to do to get started with predict is just load some test data. So the data that you'd feed that model, right, into a Spark data frame. So I'm going to run this cell. What I've done here is I've actually copied the path from my Lakehouse table section of this data frame test. My teammate, Misha, who trained this model, has kind of helpfully put test data into the Lakehouse that I can use to apply it in advance. And then we're just going to display that test data to sort of take a look at what we're feeding our model. Now, you remember on that model artifact page, we saw the inputs, so the signature for that model, what it expects in order to give you a prediction. And here we're seeing basically values for all those inputs in the test data. So we have the same credit score, the age, the tenure, all of those fields. And if we go to the end, we see the only thing that we don't have is the prediction, right? The value for the churn, which is going to be a 0 or a 1, a Boolean just telling us what that model expects. So in this kind of simplest way, what we're doing with predict is we're getting that prediction, that 0 or that 1 value in that column using this function, using our artifact and feeding it data. So the first thing we're going to do after that data is all set is instantiate an MLflow transformer object, which sounds more complex than it is. Basically, we're creating this object that is responsible for helping us generate batch predictions. So we need to specify some values. And these are the ones that you saw in that code template on the model artifact page. So in this case, we're actually using the churn model version 4 as we're specifying those bottom two parameters. The first parameter is a list of the inputs that we're going to feed to that model. And then the second is the new name, so a new string that represents the name of the column where we're going to put those predictions. So we're basically going to add a column called predictions for the outputs onto that test data frame that I just displayed in the output cell above, and that's where the predictions are going to land. Now, for developer flexibility, you can actually apply predict with several different APIs. So there are different ways to invoke the function. You can use just that transformer, the kind of most direct way. So it's really just one line after you've done that. Predictions equals model.transform, and then you're feeding it the test data. And here we're going to display those predictions. So this is often, I think, the most common way, according to some of our data, that users will do this. But I'll show you two other ways if you want more flexibility too in the code first fashion. So model.transform is generating these predictions, and now I'm going to display them as a Spark data frame here. Let's just give it a second to plop out that table. And what we're expecting to see here is the same input columns that we saw in the cell above, but now at the end of that table, there should be a new column, predictions, as we specified in the cell above, and should have the 0 and 1 values that are those predictions for churn. So if we pan over here to the right, we now see this new predictions column. We see 0s and 1s, which correspond to the churn value. And maybe that's deceptively simple, but that really is the output of this prediction scenario. So we took our test data, we fed it to the model, made sure it was in the right format, and now we've gone ahead and generated those predictions. Before I move on, I just want to highlight that there are other ways you can invoke predict. So once you have this MLflow transformer object, you could also use the Spark SQL API if you're more familiar or more comfortable with that syntax to get the same predictions. So in this case, I need to specify some of the same fields, and then I'm using this sort of embedded SQL statement with the SQL transformer to generate the same predictions. Again, it's still predict. This is just a different way to do it. And right here, what I'm showing is just those end prediction values. I didn't append them to the table, but we'll see that they're the same. The last thing you can also do is apply predict with a user-defined function. So here I'm also bringing in that UDF import. I'm creating a new myUDF variable that holds my model converted to a UDF. The features that I'm going to feed that model are just those columns from that original test data frame. And now I'm going to display that new column sort of appended to that test data. So I'm taking the test data frame and I'm adding onto it a column called predictions that has generated its values in line using that UDF. And we're going to see here when we run that code cell, we get the same output as we did when we just used the transformer API 2 cells above. So let's give that a second to load. And then we see here again, we have all of those feature columns, but let's scroll to the right and our predictions are right there. Now, the last thing you might want to do in a situation like this, you have the predictions in the notebook, but you want to persist them somewhere. Maybe you want to go and build a report on top of that data, or you want a teammate who's working in your lakehouse to have access to those predictions. You could go ahead and write those predictions in the Delta format to your table in your lakehouse. And then what's going to happen is they will be persisted there for other people to use or for you to use in a different context. So let's let that code cell finish, and then I can show you what I mean even in the Lakehouse Explorer. So it looks like that has worked. So now if I go up and I should be able to refresh this, right? This table list, we see there should be, cross my fingers, and I was right this time at least, there's a new table for predictions. So that all went off without a hitch. So just to kind of recap, we started by taking test data from this lakehouse in this data frame test variable, putting that into a Spark data frame. So we had it available for our model. We loaded our model in. We created a transformer object. We fed the test data to that model, we outputted predictions, and then we wrote those predictions back to the lakehouse. So now they live in the same place, and you actually have access to that whole table with predictions kind of plopped on to the end. So that's a kind of standard code first flow for this batch prediction scenario. I also want to show you, though, how you might get started with this process and actually do a kind of same flow end to end if you have less familiarity maybe with that API. Maybe you don't want to sort of write the code yourself or consult documentation. Well, there's a solution for you in Fabric 2 right now. So let's say I head back to my lakehouse. I'm basically going to redo those steps, but I'm going to do it in a way that lets me take advantage of some of these UI experiences we have built into Fabric. So let's say I go back to this churn model. I want to click on artifact or sub-artifact 4, so version 4 of this churn model. We see the underlying files. That's what I just used in the notebook to generate predictions. But if I wanted to do the same thing without writing any of that code myself, you remember there was a second option under this apply this version button, and it says apply this model in Wizard. So if we click on this, essentially what we have the option to do is to fill out a series of UI-based steps that are going to just pre-populate that entire code command for you. Everything from choosing a location for that input data that you're feeding into the model, doing the mapping to the model correctly, and then writing those predictions generated from the model back to a lakehouse. So let me show you what I mean. In this first step, we want to select the input table. So we're in our Fabric Data Science workspace. We see this customer churn lakehouse, and we're going to see what input tables are available there. Now, when I was in the notebook, you remember you could copy the path from the Lakehouse Explorer and read that into a Spark data frame. Here, I had the option of just clicking on that data frame test table, and it's going to give me a preview. Let's just give it some time. And then I can use the data there and specify that that's sort of what I want to feed in. And I've done that without needing to, display anything or kind of load anything in myself into a Spark data frame. Alrighty, okay, so here now we've kind of previewed this data in this test data frame. We have all of those columns. They look good. Again, we're noticing that we don't have predictions at the end, and that's kind of what we expect. So now let's go to the next step. And here we're going to map that data from the kind of test set to our model. So you can think of a model really simply as kind of a black box. These inputs are what the model expects on one side. The output is the prediction on the other. So in this step, we're feeding the right values into those slots on the left side of the box, basically. So it expects, a credit score of this data type, an age of this data type, and we have the option to actually choose those columns from the UI from the test table we've selected. Because we've named those the kind of consistent, correct way, they've already auto-populated for us, but if we hadn't done that, we would have the option to kind of switch around what we're feeding to the model. I'm going to click Next. And here, now we're going to be prompted to actually create a new table in the same lakehouse for the predictions. So in the code first flow, you remember that I wrote that Spark data frame to a new table called predictions, I think. Why don't I just call this espresso, 2 S's, predictions. It's going to be in the same lakehouse, in the same workspace, and click on Next. Here, we're doing kind of the right side of the box. So we put those input values into the model. The model is going to spit out a prediction. And here we have to name the column where that set of predictions is going to land. So this kind of corresponds to that output column field in the ML flow transformer on the code first step. I'm just going to call this churn. I'm going to go forward. And then the last thing I'm going to do is choose a new name for a new notebook that we're creating that's going to kind of orchestrate this process or run the code for us. So I'm going to call this espresso prediction demo. And we see here that we have that code snippet generated. So if we already had a notebook, we didn't want to generate one, you could also just copy this. We see it's the same as the template from the model artifact, but the values are filled in. I'm going to go ahead and click on Next. And now we have a summary of what we've done in these steps. So again, just to review, just as we did in the notebook, if we were doing this from a code first approach, we chose, the model and the version. We specified that. We needed to locate and load in input data. We needed to feed that input data to the model in the right way, according to what the model expected for its different input fields. And then we needed to do something with that output that's coming out of the model, the predicted value, write it somewhere. And so we've kind of simplified that process or generated code for you for a user who might have less familiarity with the API or who might want to apply a model but isn't really a developer or a data scientist. So in this case, I can click on Create a Notebook, and we have done the same thing I did in the previous step in the notebook flow without having to write any code. If you weren't here with me listening to me talk, that probably would have gone even quicker, but you get the idea that you can sort of do that quickly with the flow that we have on that apply model button. And then here again, if we go through the steps, it's the same thing. We're reading data from the lakehouse with this ABFS path into a Spark data frame. We're going to feed that to the model.transform line. The model has been specified according to this ML flow transformer, all filled in. And then we're writing those prediction values in that data frame at the end back to the table. So if we click on run that cell, let's cross our fingers and give it a second. And then I can show you where those predictions actually ended up landing with this second UI first code generated method. I'm going to take a sip of my coffee while we wait. Alrighty, pretty fast start time for Spark. And it looks like we've succeeded. Almost. I get a little bit ahead of myself. Let's just make sure that that finishes. Okay, so that was executed under a minute. And what we should now expect when we go back to our lakehouse in this workspace is a new table that includes those predictions at the end, and it's called espresso predictions according to how we named it. So I'm going to head back to that workspace. I'm going to head to my customer churn lakehouse. And sure enough, if we look under the tables section as this is loading, we have a new espresso predictions table. So let's open the preview and see if our values were kind of successfully landed there from the model. Okay, and so now if I scroll to the right, oh no, I don't even need to. It's already there. I thought I had to scroll. Yeah, if we see on the right, that rightmost column, we now have a churn value that's been added. So again, we took that test data frame, we fed it into our model, and we wrote the results appended to all of those input feature columns to a new table in our lakehouse where it lives, where we can access it from different places, where our teammates can access it, and that's the whole flow. You can do it from a notebook directly, you can do it through a UI-guided experience on the model artifact page, and that's what we enable. Now, I don't want to get carried away, but just to show you kind of where you can go from here, the reason we generate predictions in a case like this is for a business problem, right? So we're looking at churn. Now we might want to go and show off our results, kind of take a look at the same data in individual form to see kind of how those predictions line up, how it might kind of slice and filter with other fields. Maybe, you know, location or, you know, any of those factors according to the bank, you know, maybe a certain range of credit scores, anything we saw. So a natural kind of scenario for this is Power BI. And thanks to the integration in Fabric, we noticed that our lakehouse actually has a data set that's already kind of created for you and by default. And if we wanted to go ahead here, we see that our espresso predictions are there under a table. We could select them. We could create a report, auto-generate a report, share the data set, you name it. So this is really the end of one flow, but the beginning of another. And by taking advantage of the predict function in the Fabric workspace with that artifact, we have allowed users a few different ways to get value from the model and then share those predictions with other people for business insights. And that kind of continues the story, but I think that's a story for another day. So yeah, thank you, Estera, for letting me show that capability off.
Thank you, Rin, for showing a very deep dive into the predict function. The demo you showed is covering end-to-end story. Now I'm feeling empowered to start using it, to try on my own. I hope our viewers as well. In terms of addressing this, like different scenarios, I'm wondering, as right now we are like lots of predict functions are done as a batch mode, meaning that every night a customer is running a predict for specific like data. Sometimes, for example, the IoT scenarios are requiring the real-time processing. And I'm wondering how predict function is covering and addressing those needs, meaning the real-time prediction.
Absolutely. So right now, this model consumption experience in Fabric for predictions is limited to batch scenarios with predict the way I've shown. So you could go set up a notebook to do batch jobs, batch inferencing, and then schedule that notebook to kind of set up a pipeline. But there's no need to fear. We have a lot coming down the line in the future. So real-time predictions, that's a key scenario for model deployment. We're talking about setting up a durable, persistent URL behind which you have a model that's being served, and you can kind of hit it in real time and get the predictions back, something that's highly available, low latency. You might also want to configure whether that endpoint is kind of up and constantly running based on traffic or whether it's scaling down to zero to save costs. Those capabilities are coming. So we're working on deploying those model artifacts to endpoints that then you can use from other Fabric experiences and that you can use from your external apps. So the batch prediction scenario with Predict is really just how we're getting this started. There's a lot more to come in terms of real-time scenarios and laying the foundation for a fuller deployment and an MLOps story really in Fabric.
Super. Thank you so much. I believe that we can wrap the recording, the video right now, as tons of new knowledge. Thank you for all the insight, especially that you are the part of Fabric product group that is focusing on the data science experience in this Microsoft Fabric service. So again, thank you so much.
Thank you. It was my pleasure.
Thank you for thank you for all people watching this episode. Remember to subscribe to the channel, hit the like button. Also to leave the comment, leave the question if you have any ideas for the demos you would like to see in the next episodes. We are happy to take them and cover and also provide some extra resources, extra demos, and the instruction, the guidance, how you can use Microsoft Fabric for your data science purposes. Thank you again, and see you in the next episode.
Bye. Take care.